Hello, everyone. Uh, I welcome you all to Let's Learn Together. So, today we'll not talk about any chapter, we'll talk about a topic which is motion, rest, and time. So, we'll understand what is motion in the first place, then what is rest, and then what actually is time. So, I hope that you all are able to see the whiteboard that I have shared right now. So, in this whiteboard, I'll first of all write down motion. So first of all, what actually is motion? That we say that an object is in motion, then what does it mean? So imagine that you are traveling by a car or by a train, say that you are moving from one place to another. So the person sitting next to you in the car, according to him, you are not moving. But according to a person who is observing that car moving from outside, he will say that the car is moving. But you will say that the surroundings are moving. You will say that we are at rest, the surroundings are moving, and the person will say, no, we all are at rest, and the car is in motion. So, motion is basically the movement of an object. I'll write it here. So, I've written it over here. The movement of an object with respect to surroundings and time is termed as motion. When all these criteria are satisfied, then we say that the object is in motion, or else we say the object is at rest. So now we'll talk about that what is rest. When do we say an object to be at rest? So the opposite of motion is rest. So motion was the movement of objects with respect to time and surroundings. So means when the object changes its position with respect to time and surroundings, then the object is said to be in motion. Now, just if we do it the vice versa, then when the object does not change its position with respect to surroundings and time, then the object is said to be at rest. And absolute rest and absolute motion are not possible. What does absolute motion means? Absolute motion means that all the objects, including even the small atoms to the whole multiverse or universe, if we talk about, so all of them are in motion. So all of them cannot be at motion at the same time because something will be there in the multiverse or in the universe which will be at rest, like the black matter that we have in the space. So I'll not go now deep into black matter. It's a very deep topic. So now absolute rest means that all the things are at rest. Now that's also not possible. We know that the air is moving, the and even if you are at rest, if all the people are put at rest, then also the earth is rotating, then also the solar system is moving around in the galaxy is moving around in the universe, and we don't know how our universe is moving. according in the multiverse. We don't know it. So now, what is so the question arises that what is not time? We talked about motion, we talked about rest, and both of them are related to time. See, if this is a distance to be covered, we start from here and end at here. We have taken some time to cover this distance. To cover this distance, we have taken some amount of time. So now, what is that time? So first of all, I'll make some perceptions about time that uh, people commonly think about time to be. So time is like, they may say, like Mozart's metronome. Sorry for the error. So I'll not go deep into Mozart's metronome. So Mozart's metronome means that time is a constant thing. Time is constant everywhere in the universe, in the multiverse. It means that time is constant everywhere. Everywhere you see, time is constant. Is that so? So the answer is a big no. Time is not constant everywhere in the universe. So what is time? It's a relatively simple question, yet it is the key to understanding Einstein's theory of relativity. Now, now, it, now here from here it gets pretty complicated. And according to Sir Einstein, time he defined as a sheet. Be it to be a sheet. It's constant, but not constant everywhere. Like we know that our sun has a gravitational pull, and like our sun, our other stars in the universe also have gravitational pull. So anything that has gravity, suppose this is an object which has mass, so it will definitely have gravity. So it will bend the time. What do you mean by bend the time? It will create a vent in the time. And what will happen? If you go from here to here, you will take less time. And it's pretty obvious. But if you want to go from here to here and then continue your journey, then it will take you longer time. Means in this scenario, the time will slow down for you. And in other places, it can also be like uh, this is what we are talking about. At some place, more gravity is there, so there is a vent in time. At some places, there might be zero gravity. So at places where there is zero gravity, they're out of time. They don't have the concept of time. So at zero gravity, we don't have time. But we all know that yes, we are stuck in time. And time is the reason why we grow in our age, why we see objects moving, and at the end of our life, we all die because of time only. So, what basically is time? Time is not constant everywhere. First, we have to understand that time can be slow or fast, and time of a place depends on the gravity of a place. Because we discussed, if more the gravity, the slower the time will be for a place, and the more the and the lesser the gravity, the faster the time will be for an object. And it is said that time also depends on the speed of an object. So now you'll say that how does it depend on the speed of an object? So physicians and physicists theorize that uh, the uh, the more closer an object moves to the speed of light, the slower the time gets for it. that if you have seen movies, then in that you will see that people who run very fast, the surroundings get slowed down. So that slowing down of objects is based on this concept only. The person is moving really fast, so everything around him gets slowed down. Okay, and like in the universe we live, it is a three-dimensional object because we have length, breadth, and height. So, in what dimension can we talk about time? In what dimension is actually time? So, it's in the fourth dimension, as time gives us directions. Direction means I'm talking about north, south, west, and east. It gives us these directions. That's why time is not in the third dimension, sorry. It's in the fourth dimension. Now, when time was theorized by Sir Einstein, then a very interesting topic was also there related to time travel. So I'm representing it by TT, time travel. So many physicists approached with their came with their theories, with the different theories about time travel, but they were not they were not accurate enough that they can be theorized and they can be worked further on to make a time traveling device and what we generally call as time machine. So we all know that gravity defines time of a place. The time of a place depends on the gravity of a place. So if this is time, which time is a loop. So if I represent this loop like this, so in this loop, if I am at this place, I have to go at this place. So I say this is the current time, this is the future, and this here is the past. Okay, so we know how to slow or fast the time of a place. So we know how to control the speed of time by controlling the gravity of a place. If in the current time I increase the gravity, so it will take me more time to reach the future. And if the gravity is lessened, then I will quickly reach the future. The time taken for me to reach, suppose 2050, will be lessened in this condition if the gravity is less. And if the gravity is more, then the same time will expand. It will be more. So this is what how to slow or fast time. But the question that we are talking about is how to travel in time. Means that I am at one point of time, I want to travel. Suppose I am here, I'm at this point of time, and I want to travel in this point of time or in this point of time. So how to do that? So I'll draw the same diagram again. So we all know that time is constantly moving in a loop. We cannot stop time. It is not currently it is not in our control actually. So this is time. It is moving around like this in a loop. So if I want to travel in this point of time, so it is certain that from this point of time I have to create a vent. Means मुझे एक दरार यानी कि जिसे हम कहते हैं खला. I have to create that vent in this time. So what will happen that it will break through the time and create a path for me to the other time, what we call as a portal. So for that also, if you remember the previous theory, so it was that to how to slow or fast time. So what we created like this over here was also a vent, and this is also a vent. So means for traveling in time we need to have control over gravity. So according to me, that for time travel, you need to have total control over gravity. So if I am taking TT as time travel, the time travel equals to gravity. So gravity is the key to take control over time. See, we cannot stop time. We can travel in time or slow down the time, but we cannot stop it. To stop it, we need to have zero gravity, and in zero gravity, we cannot survive because we'll not have the atmosphere anymore. The water will go in the space, and we also, I don't know where we will go. So this was what I wanted to explain you about time, motion, and rest. These are my theories, or not now, I'll call it, not now, I'll not currently I cannot tell them as a theory, as they are not, as to be considered as a theory. Your concepts have to be approved by the there's a meeting. You have to prove it with an experiment that yes, your theory is correct. Like when atom was being discovered, so the research of atom was started by Sir J.J. Thomson, and Sir Rutherford ended it. So before Rutherford, three people gave the shape of atom, but Rutherford was the one who gave the most accurate shape with the golden sheet experiment. So like that, you have to prove your theory. So I'll not call them my concepts actually, or my conceptions, I'll tell them. So according to my conceptions, for time travel, we need to have total control over gravity. uh, Currently I cannot summarize or tell them as a theory. So let's summarize that what we have learned in today what we have learned today. So first of all, we learned about motion. I'll represent it by M. So motion is when an object changes its position with respect to time or surroundings. Then we talked about rest, and then we talked about time. Rest was when the object does not changes its position according to time or surroundings, and we had a lot of discussion about time, that what is actually time. So that was all for today. Thank you very much. But before ending this video, I'd like to make an announcement that Let's Learn Together means I will be hosting a webinar next Sunday sharp at 12. So those who are interested, I'll start the live stream sharp at 12. So those all who are interested can join that live stream from our channel, and you all are requested to please click on the red button of subscribe, like this video, and press the bell icon to get all the notifications and updates on our channel. So यार कर दो यार. It's just one click away. And the next Sunday we'll be hosting a webinar. I'll also share the link of the webinar, how to join it when the live stream is started. Those who are very much curious can join the Zoom meeting, and that at the end of the session, I'll also try to take your doubts, and I'll try to make it interesting. So the topic of the session will be declared tomorrow. So it's a surprise for today, and the surprise will be disclosed, means surprise se parda kal uthega. Thank you everyone. Bye bye and have a nice day.